All right, so we're honored to have Sue Chrysler here, who has nothing to do with Chrysler Corporation or Fiat, for that matter. I see I can describe her as a Minnesotan who's become a Texan who's trying to figure out what she is. She's done a lot of work with TRB, which has really been quite interesting research. She's worked at TTI for a number of years. She was Iowa for a number of years. And the Iowa exposure has taught her tons about simulators that she didn't learn at TTI. And TTI has taught her lots about driving on roads. So I think she's very appropriate to talk about the topic we had. Did I make something up that's good enough?
I was happy to be here. Jim Sayer has pointed out that I was first here almost to the day 22 years ago when we both started our first job. So I've been coming here for a long time. So I'm going to talk, this is somewhat based on a workshop that we organized at TRB this year, because over the years in human factors research in particular, it seems like this divide has gone up of whether you're a simulator person or not, and those who have simulators will use them for all sorts of things that maybe they shouldn't be using them for. And as simulators have become less and less expensive and more accessible, we, Linda Boyle and I, who's one of the AAP editors, and Newt and I have talked about this too, you know, we keep seeing some really bad research, often behavioral research conducted by some civil engineering professor, no offense to the civil engineering graduate student. You know, they have no reason why. I mean, I wouldn't know how to run a civil engineering study, and I'm a psychologist, so why would they expect to be able to run a driving simulator study? And as more naturalistic data have become available, I think many of the people who, you know, deal in that world dismiss every other research methodology. So I'm not sure I'm going to have a big answer to this, but I'm certainly going to have some questions. And I've got some examples. I was at TTI for 10 years and left and was the research director at the National Advanced Driving Simulator at the University of Iowa for 3 years, and then I recently went back to TTI at the beginning of this year. So some of the examples I may be talking about NADS, National Advanced Driving Simulator. So this is kind of my framework of driver behavior research that, you know, you can do part task testing, reaction time testing, HMI testing on a bench test, and have very high level of control. And you can go all the way up to naturalistic driving studies and have no control, but your ecological validity and realism is going to expand. But from a statistical standpoint, you know, sort of philosophy of science standpoint, you really need that experimental control to really ascribe causality. If you're trying to, you know, evaluate some traffic control device treatment or some HMI in a car, you know, the struggle I'll talk about is, you know, where do you find the appropriate control condition in naturalistic studies? And I think the biggest issue that we see as TRB committee chairs and paper reviewers and stuff is that people are fitting their research question to, I'm saying it backwards. They're not thinking about this. They are not thinking, I have this tool. They're thinking, I have this tool and it can answer every question I have. And they, you know, so a lot of times, this is a very common thing going back to my time at 3M of, you know, looking at different things, and I'm probably guilty of this in some of my early work, but I have definitely seen people looking at gap selection using a simulator with a single screen, so you have absolutely no view of the cross-traffic, and making all sorts of great claims about gap selection when you had a 30-degree field of view. But it's some poor graduate student in the lab, and they said, we have the simulator, go do something with it, you know, and so we spent a lot of time talking to our students about framing their research question for the tools available to them. I would argue, not John, I don't probably get a fight over this, having worked at a very big simulator with a big motion base, that I'm not sure I would, after being there, want to study speed selection without a motion base. Because it's a very different deal when you have motion about your perception of speed. Also, the notorious intro psych problem of getting all your subjects from Psych 101 class. I don't think Country is as guilty of this as any other places are. So let's say we want to talk about is fluorescent yellow green school crossing signs a product that I was involved with developing at most of the studies that were done were this speed, because it's easy. I can stick a tape on the ground, walk away, collect speed, put up the new sign, go back, collect speed. Oh, there was no effect of the sign. Well, why would people slow down if there wasn't a pedestrian there? And that wasn't the intention of that sign. Was not to get people to slow down. The intention of that sign was to get people to look for pedestrians. So should you be measuring something that has to do with looking for pedestrians? So I think just walking through, working with students in particular, trying to get them to, everybody thinks they're measuring safety. We get a lot of people that are claiming all sorts of safety benefits, but to get them to sort of operationalize that into something. And sometimes, I purposely worded these. This doesn't talk about what tool I use to measure response time and eye gaze, because I could do that in a simulator, or I could do that with naturalistic data. But the thing I'm measuring is what is important to think about, not necessarily the data source or the piece of equipment. I can measure eye gaze with a really expensive eye tracker in a simulator or in an instrumented vehicle. If anybody can figure out how to get an eye tracker to work in an instrumented vehicle, come talk to me. Dylan is nodding his head back there. Or you can sit and manually code naturalistic driver keys. So I'm not preaching in the choir. Some of you know David Shinar from Israel, and he was one of the speakers at our workshop, and he did such a nice job of summarizing. I'm just using his slide with attribution, but. And I'll jump to the conclusion as you read. The conclusion of the workshop was both methods have their pros and cons. And I think the art of research is figuring out how to frame your research question to the tools you have available to you. And how you want to balance, yes, there is a bias in naturalistic data. People who sign up to have stuff stuck in their car are probably not the worst drivers on the road. And they're probably overly educated. I think we have the data to show that. I mean, they're much above average on many counts. Simulation, depending on the fidelity of your simulator, you can get quite immersed and have a very appropriate screaming, cursing. We kept saying at NAS we were going to put together the blooper reel of people cursing when they got into crashes. I've seen some very nice little farm ladies in Iowa, Cyrillic sailors, as they're running into the back of the side. But you have sickness issues, which we'll talk about. I'm going to go to the next one, so we talk a little bit about what kind of study design and sort of driver demand characteristics. And I think this is, for me, the biggest one, depending, again, on the question. Like, you're talking about behavioral adaptation. Can you really study behavioral adaptation in a simulator? I mean, you may not have enough time to adapt, and plus they always are knowing that they're being watched. And, there's this demand characteristic of, coming down the train, and I'm going to go do the study, and they want to be a really good subject, and everybody's on the best behavior. So I think we prove in naturalistic data by the stupid things people do, even though they know the camera is there, that they forget the camera is there. But Dan McGee, he calls it the nose pick moment. And he knows that they have forgotten that the camera is in the car. Simulation can be low cost. or very high cost, but I think it will never be as high cost as naturalistic data in terms of handling the data. I mean, if you want to do minutia, minute behavioral coding on sim data, it can be as excruciating as on NDS, but you don't have the geocoding issues and all that kind of stuff. So I'm going to talk a little bit about fidelity, because everyone has a high fidelity simulator. Every article I've read, whether it's a desktop, they say I had a high fidelity driving simulator. This is a real thing. I found this picture on the internet. And it's a golf cart with a video game on the front of it. And I didn't quite understand, because it's hard to see it here. This doesn't really map where that road's going. I don't know if this is meant to be like in the, you do it in a parking lot or something. It's just basically our public. So we obsess over fidelity. You can have, gaming pedals. This is actually a real seat. This is a NATS mini sim that's got a real steering wheel, real car seat. Single forward screens. But all of those things, maybe they matter. But it depends on what you're at. I mean, if I'm studying traffic sign comprehension, does the road sound really matter? I don't care. You need some. And so I think people get very obsessed over all of these controls without thinking, does it matter for their study? And yet at the same time, I've also seen a lot of people use the good old Logitech steering wheel available at any Best Buy, and it's really touchy and it's really small, and older drivers really have trouble with it. And make all sorts of steering, conclusions about steering, and say, I would have done that with a real steering wheel. It's handy to have those thumb controls over the reaction time. Pedals are interesting because most of the portable pedals, they come from the bottom, and they really angle different. It's a different foot position. It's hard to sense it compared to ones that are suspended from the top. It's a real sloppy measure. It's hard, if you have usually in simulator, in a full cap simulator, probably in yours, and there's a spring potentiometer in there that's getting stretched, and you forget to recalibrate it, and some of the CAN bus data that you can get from Naturalistic, it can be kind of noisy, or it's a sampling rate issue, and there's just a lot of slop. When you think about it in your gas pedal, there's just some slop in there. So it's hard to know we're talking about point of deflection on a curve. We often have trouble finding point of deflection on when they've, we've passed the speed limit sign and they're supposed to slow down. Well, how do you really know when they decided to slow down? Because they've been kind of modulating the gas pedal for the last 10 minutes, and where is that point of deflection where they really have released the accelerator? Because I have to go past it and the data come back, and there actually is calculus involved. I hate to you do use calculus in real life. So again, this is again very common thing. These paddle shifters are also, you could either turn signal. Here's I had a rental car with one that was very confusing to me because it was also right next to the vent control, which was also a wrong dial. So every time I wanted to turn the air conditioner on, I was going to put it in reverse. So I think the biggest, probably most noticeable thing is display. So you get some nice high-res things, you get wraparounds. Projectors are nice, but they can be kind of low output. They're low brightness often. There's a lag in them. Is it a real curved screen? Is it angled to be curved? Some sims I've been in, there's RTI makes one, like George Mason University has it. You're actually in this sort of pod with the screens, and then that whole pod moves. So you're always seeing the screens, but you're getting some motion. And that's actually really convincing. I actually tend to get sim sick. That's why I ended up in this field. So So I'm a good canary in the coal mine. I never got sick in NADS. It's the only simulator I've ever got sick in. So, you know, do you do picture-in-picture on the screen for the mirrors? It sort of looks goofy. They're kind of at a different distance. Some people, you know, NADS actually is rear projecting, so it's a real mirror there, and you're just seeing the screen from behind you. Or you can do this is Federal Highway Sim. They just put it LCD in there. Have, you know, some high frequency vibration to get road feel, which is actually very effective. I mean, NADS has 13 degrees of freedom. You know, this whole thing is on a hexapod. It's moving on an XY axis. It's pulling 27 Gs, and then there's individual actuators on each wheel, and the whole thing spins. So, but we've done studies looking at turning various parts and pieces of that motion base off to see what difference it really makes. But again, it depends on what you want to study. Then there's the butt kicker gamer. It's also something you can buy, and it's just, I mean, it thumps your seat. Which, you know, if you're gonna do virtual rumble strips, maybe that's all you need. You know, I don't need a 0.7 lateral acceleration generation. I just need something to kick me up. I think the other part of fidelity is in scenario design, and this is, you know, when people report their simulator equipment, it's always, I had 130-degree field of view, blah, blah, blah. It's always the physical stuff. And I think the longer I've worked in simulation, the more I've come to appreciate, especially in controlling sim sickness, there's a lot you can do in the scenario to control sim sickness. Probably more than you can do in the display technology. I mean, I'm just avoiding certain things and turns and you know, this is Lane Road. This is a realistic, photorealistic, geospecific place that has been modeled with thousands of photos taken and mapped, texture mapped onto the polygon in the sim. RTI does some really nice lighting effects. You know, there's a little window going down. You can see that. You can, you know, do day and night. The projectors have gotten faster and have a better dynamic range with a true black, so you get a much brighter, you know, range of brightness. But you can, having all of that really good level of detail can also increase your sim sickness, because all of a sudden there's all this stuff to look at and stuff flowing by in your periphery that gets you sick. So sometimes you want to get that further away from the roadside and lower your sickness rates. So, okay, everybody wants to upgrade their sim, and probably you guys are going to kill me later because you're probably about ready to put in a proposal to upgrade your sim, right? So does any of it really matter? And again, I go back to it depends on your research budget. This is a study, the Federal Highway Exploratory Advanced Research Project study that compared Federal Highway Sim, which is pretty high fidelity, it's got some motion, to the big NADS, to the RTI with a hexapod at Montana State, and a mini sim, which is just a buck with 3 screens, no motion. And they, this is a real place in Iowa, and there's this was a speed reduction coming into the town. There were some signing and pavement marking treatments to get people to slow down coming off of this rural highway. So they recreated it in the virtual world on all the simulator platforms. They also did this for a large roundabout in Maryland. So they had speed data, loop detector speed data from these locations. And then they put people in the sims and had them drive. And so this is the big NADS with motion. This is Federal Highways. So this is speed in miles per hour and then speed on the road. So this is the average speeds for the drivers and the average speeds, you know, measured on the roadway. So, you know, with the motion, they're driving a little bit, say it wrong, faster in the sim than on the road, but they're consistent. It's parallel over the full range of speed. They're, you know, that offset is consistent, and what you see in the other ones is it's slightly skewed. Like this one, you know, they were a little bit faster at the low speed, but as the speed increased, they actually started driving slower than. But overall, this is for, the lowly mini sim down here. They didn't do too bad. There's no motion, there's no wraparound, there's no, I mean, it's, So, was this the question that was being asked? I mean, this whole study was about this level of fidelity needed for different things. So in the similar response, similar findings were found in Maryland for the speed. So it sort of questions, well, how much do I really need? And again, if you're going to be in there driving for a really long time, people get bored, and being in a car and having it 360 degrees kind of keeps them engaged in the task. I mean, being in a, knowing you're in a conference room on the third floor in the sim. I used to have a cabin on the third floor in a cabin. They start looking around, and they start getting curious about how the thing works and how it's set up. And I mean, I've been in some simulator labs. So I was really having air conditioning issues. So their solution was they just put a box fan, like basically right at the front of the car. So there's this fan sitting there. I think you're losing immersion here. So I would argue that simulators may not translate directly, although this study said they were pretty darn close, that the speed simulator really was pretty similar. But comparing conditions, if you're going to do a design experiment, the relative performance of those treatments should hold in the simulator. And like, sort of flip that around, that NDS data are absolute, but it's really hard to find the appropriate control condition. Either the appropriate control person or that same person on that road when the light didn't turn yellow, it's finding what is the appropriate comparison for them. So I'm going to give you an example of the relative performance. This was a connected vehicle study that we did for NHTSA when I was at TTI and we were partnering with Iowa. So we did 3 different platforms with the same in-vehicle tasks. And I won't belabor the task, but I have an example one that I'm going to show you some reaction time data. But again, this was a very, one would say, pretty low fidelity mini sim with 3 fairly small screens, not particularly flanking, and a gaming pedal and steering wheel. Likewise, this was the TDI setup, and then we took our instrument vehicle on the track. The instrument vehicle that Dylan built, by the way. My team did. So I want us to look at speed first. These were across the different secondary tasks, and I'll tell you about one of those secondary tasks if you need to learn more. But I guess what's interesting to me is that these lines are pretty parallel. That across the 2 different kinds of simulators and the test track, that the performance from baseline to the different distracting tasks, the decremented performance was comparable. And if I converted that to a percent or a z-score or something, those lines would be atop each other. You start to see a little bit difference, more separation when you look at things like standard deviation, look at other measures. Maybe it starts to wonder, like, was there something going on? Is it this one that's high or low, or is it this one that's high? You don't really know, and I'm going to show you one in a minute where they're really different from each other. So one of our tasks was a alert, kind of warning task, somewhat. I forget what we had. This is a ping pong ball with an LED in it, but we had a really scientific term for it. Semi-hemispheric opaque. This is basically, they get a beep, and the beep is to say, hey, there's something going on, look at that light, and now your task is, if the light is red, you're supposed to press the button, and if it's green, don't do anything. So there's a decision, so there's a little bit of a memory load, and then we could play around with the probability of red and green and different incentives, but that's not what I really want to talk about. So the response here is how fast do they push the button on the stalk when the light's red. And again, we did this in the 2 simulators. Here's my beeps and lights. They also had some other tasks. So this is the response button. There were some other memory load tasks going on. So they're pretty loaded up. They're driving, they're trying to remember signs, they're beeping. And then on the car, we put this out on the end of the hood. And then these were some peripheral detection tasks too. Eye tracker. So, go, no-go decisions, whether or not you got a beep or a warning light to respond to. The 2 sims were right on top of each other, which was nice to see, even though they were set in different simulators. Something's going on with the visual warning on the test track, and something's really going on with the visual warning over here for the test track in terms of missed events. So they either got a beep or they got this light perfect. So what's going on there on our test track?
People are slower on the track.
People are slow around the track.
Paying attention.
Paying attention to the road. I'm gonna go simpler and just say I couldn't see it. It was too bright out. I mean, it's simply, they just kept missing them because there's a lot of ambient light outside. And these little LEDs in the periphery just weren't bright enough. So does that mean that a test track is better? So if I had only done that study on a test track, what would I have concluded? I would have concluded that, auditory warnings are better, they're faster, they miss you over, and we should all be able to do them. And maybe that is the right conclusion, because you always are going to have daylight issues. Maybe we should have done the study day and night. I don't know. So I think this is one example where having both the simulator and the test track data made us sort of stop and think about it and say, oh, well, wait a minute, maybe we didn't set that up right. Like, maybe we should have pilot tested better and gotten some just noticeable difference measure in the lab and in the test track so we could have equated the brightness. So Monday morning quarterback all day long. So Paul's nodding his head. Of course, NHTSA didn't let us redo this. So Paul asked me to talk about sort of what's new, and I'm going to, again, borrow from my colleagues. I haven't been back at TTI long enough to talk about what's new, but we are doing some cool stuff with LiDAR. David Noyce, who's the chair of civil engineering at Wisconsin, and one of his postdocs held in Santiago, who down are doing some very cool LiDAR stuff. I think the news, you probably went to school with Calvin.
No, but we met that truck.
Yeah. And then my colleagues at NADS were doing a couple interesting things with our eye tracker in the simulator. And then also they're starting to apply some of the simulator studies and using some of those algorithms developed from that and trying to apply to NADS. So don't ask me too many questions about this. You have to call Kelvin, but he was kind enough to send me some slides. So they go out and take LiDAR, laser scanning point data, and it gives you terrain data. And using some machine vision, it can, they take GPS, GIS, they take any data source they can and, fuse them and get this, map of the world, which, when you're designing a scenario or a roadway tile in your sim, you kind of have to start from scratch in the 3D CAD software and draw it, and basically this LiDAR data is doing that for you. It's bringing in the terrain data, and I have all the hills and bumps and stuff. And then working with the graphics people at NADS, they've kind of come out a way to now, so that's all fine, but it comes in basically, it looks like a wireframe, it looks like a CAD drawing, and it doesn't look like the road. So they're coming up with ways to actually take the roadway texture automatically and say, oh, well, that's the edge line, in my data, so I'm going to put a yellow line there. And so they're really able to go out and do very, geo-specific places, like, oh, so our idea, and the Safer Sim University Transportation Center that I founded at Iowa, this is a consortium of schools that do civil engineering and human factors. So they've got a project where they're going to take one of the Sharp 2 data sites, data collection sites where they have driver data, and actually go out and map it and recreate it in the simulator, specific to the location. So I think that's pretty cool. The other thing that I thought you might be interested in is eye gaze triggered events, and I think you probably can do this in your simulator. Have you done?
We're working on that right now.
Yeah. I mean, it was very effective. I know John was trying to do a lane departure warning study, and it was hard to get people to depart in the lane. As we tricked them, and when they weren't, so we would get them to turn, and you'll see in a second video, reaching for something to do this task, and they would, while they weren't looking, the eye tracker would say, "Hey, they're not looking, quick," and we'd move them. So when they came back around, and we turned the motion off while we moved them, so they didn't feel it. They were off on the shoulder, and they didn't ever know, and nobody ever found out. And the video I have is actually this is crash warning interface metrics. This is a NHTSA project. This is possibly a longer video than I want.
We can see.
So they get this, don't worry about the headway display, that's just to keep them following that lead car is going to do something. So she's reaching, that's the forward, see how she's got her body turned? So she's following the bug on the screen, like she's swatting a fly. We were going to have her put the bottle in the baby, but they couldn't instrument the baby bottle. So there's several different, they're reading messages, they're doing mental arithmetic. So there's various different distraction tasks, and all of this is to distract them because we're going to move, this car is going to change lanes, and there's going to be a stock car revealed, and she's going to get a warning about this imminent crash. So this is changing, this was a video we prepared for NHTSA just showing all the different interfaces. We were trying different distraction tasks to see which one was most effective. So she just got pulled. That seatbelt closeness wasn't enough to get her, but the way that was set up was that if she had not fully engaged in that task, it would never have triggered the event. The event never would have happened. It was waiting for her to really have her eyes off the road. And it saved, because before we did this, you would just hope, and then we'd have to go manually look at the video and confirm that really they weren't looking when the event happened, and we would lose that trial. So then you kind of can only do this once. They get suspicious when they see it crashing. So by implementing that, you just every trial was good. So that really saved a lot. The other, I was involved with the start of this project that was a drowsy driving study, and developing algorithms based on steering and throttle input, mostly steering, to predict lane drifts due to drowsiness, lane excursions due to drowsiness. And the algorithm was very successful and could actually predict a lane departure 6 seconds before it happened, just based on your steering. Since I've left, the new studies are going to see if they can take that same algorithm and apply it to naturalistic driving data. Now, whether or not the Sharp 2 data set has adequate steering data to do that, I'm not sure. The more people I've talked to this week, I'm not so sure. But I thought you might enjoy watching people fall asleep. This was the drowsy staff study, because we ran this study overnight, because people would more likely fall asleep in the mornings. So he's got an EEG on his head for a different purpose. And he's about ready. Okay, night-night, and watch. There was a good lane here, so I'm going to replay that because you get so distracted watching him, you want to watch the lower left, because that shows the forward view of the scene. So again, this was the room full of undergraduates going back through the video to confirm that they were asleep. You know, in the sim data, we could flag every lane departure, and then you'd have to go back and look to see, was it sleep induced? And usually a big lane departure like that was. And everybody had at least one, most people had more than one. So, the other thing that's maybe on the horizon, this is a very crude version of virtual reality that is available today he's probably been here trying to sell you one. A company called Drive Square. And it's so, he's actually found a market, and it's kind of this is the crazy Russian guy. But you're in your own car, and they do this for emergency vehicle driver training, and they have swivel lazy Susans that you put the front tires on, so you actually can, you know, you're actually sitting in your own car and they have this VR helmet on. So that all the controlling, there's no expense of a buck or controls or anything. And, you know, they can do some rudimentary instrumentation of the pedals if they want, or just to like get, you know, measure response time or brake pressure. And it's now integrated with SkySim too, so you can sort of have a simulator on the go. So that's what's projecting through the VR. Now, I did VR a long time ago, and it's much better now. But I would wonder if someone that age often had trouble with older people getting the full 3D effect of VR just because of vision issues. I think augmented reality is probably more likely to succeed. I mean, this is just something I pulled off the internet of kind of this is an augmented reality display, but again, I've seen ones where, you know, you could be in a parking lot or on a closed course and you're having projected road markings or projected other, like this is not a real vehicle, you know, so you're projecting stuff, but they're actually driving a real car. So you're overlaying the simulation onto the windscreen, so you still have some basic. You know, but if I wanted to examine the effects of fluorescent yellow-green pavement markings on lane departure, that'd be great, because I wouldn't have to go out and scrape a road. I mean, I just, you know, it's really bad doing pavement markings. They're hard to remove when you're done. So, I told Shan I didn't have any answers, but I had a lot of questions. I think this first one is interesting, and I'm very open to having a discussion about it. Is the ACAST data from 2005, is that still good?
Yeah.
Okay, move on. Next question. The 100-car study, I think most of you are familiar with that. It was the first big naturalistic study. It was done in the early 2000s before there were smartphones. So what does that say? What kind of, distraction? And not everybody had a phone at all, and if they did, it was probably a flip phone. No, probably not even a flip phone, probably just a hard 10 key. You know, that was a very different type of distraction. And the sort of pressure of society to respond to a text. But the frequency with which you would be getting a text is very different. Now, if I wanted to study the effect of curve radius on entry speed, that data is probably perfectly good for that, because that hasn't really changed. Roads are still roads and people are still people. Okay, maybe the suspension in cars has changed a little bit, but I think the other one that gets a lot of our conversation time at conferences is what does it mean when you crash in a simulator? We were doing some pedestrian collision warning systems, and I talked to some colleagues at Ford, and they did a lot of sim testing. And they had people in tears. I mean, you run into a pedestrian in the sim, and it's traumatic. I mean, so when we did that study, we sort of went out of our way to make it avoidable, close but avoidable, and we didn't ever have any children with pedestrian targets. And like Liz Mazie and NHTSA talked about when they were doing the backup camera study, they had like a little cutout picture of a kid that would pop up and people would run over it and they would be traumatized, So it's sort of ethically, you don't want to traumatized. And usually, like, when we have people crash, we'll usually end the study. Because they, they're kind of not in the right frame of mind. Dylan and I talked about yesterday, can we afford to put DASs in every vehicle? Do you know, can we? Would be, it would be nice.
It's the data that will kill you.
Yeah, it's the fire hose of data that will kill you. I'm going to show quick my colleague, my manager who was here in the spring, he said he talked about this a little bit, but he's got a smartphone app he's developed that will measure all of these things just on your phone. So it's the DAS in your pocket. From the accelerometer and tying into the GPS. And then you can map it, there's a data dump and a point map. And that's just using, granted, you're not going to get lane position accuracy from the GPS on your smartphone, but that's a good data source. And it's a lot cheaper than a DAS. You aren't going to get video, but you're going to get travel patterns, you're going to get, acceleration, deceleration. And I think, the $1 million question and then when everybody argues about is what fidelity is enough. And I think it is a gradation, and it is, everybody questioned when at TTI I took apart the full, I hauled the car out because I wasn't doing the research that needed a car anymore. I was doing research on traffic sign comprehension, and I wanted a simulator I could take to Houston or to Dallas because I was studying toll road signing, and there wasn't any toll roads in the town I lived in, so I needed to get to those drivers. And I wasn't measuring driving performance data, I was just using it to present and engaging something to keep you occupied so you're not just staring at traffic signs on a screen. But my measure was memory for that sign or comprehension or some, what did that sign mean, or which lane did you exit when you saw that sign. So I had very gross measures. I wasn't measuring speed or braking, so I didn't care if I had the Logitech steering. Now Mike's come back to TTI and he does more driver performance, so he's gotten a better simulator. So I think, pick your place. Comments, questions? Yes.
I'm a controls person with a different meaning of the word control than you're using right now. And I don't know quite how to phrase it, but it seems to me there's a difference in your world between performance and behavior that you don't distinguish. You use the words. When Pat Waller was here, I used to ask her, and all I got was, well, that's a good point. And what I think we want to know is how people behave. And what we're doing is running tests and measure how they perform. Like you say, they know they're here, they know that, or they got something on, and so, and I guess the thing that I didn't, one time I went to TRV a lot when I was younger. Anyhow, I was over at the simulator they had at the Turner Center at the time, and they were studying signs, it happens. And what the guys there running it and watching, doing multiple tests and thinking about what's going on here, sort of, how does our simulator work in this situation? They told me you always want to measure speed if you're trying to evaluate a sign. Because what happens with people, their view at least, was that if they can't figure out what the sign means or they can't read it well, they slow down because you're sort of throwing the feature of time out. You got reaction time, and it always struck me, you don't know when the reaction started.
Right.
The person often, things that we were doing became apparent. If there's a car, then it's obvious it's going to turn off the road. You don't slow down because you're not going to run into it. But if that person changes their mind and turns back on the road, turning person, then you're in trouble and you have to do hard braking. And you're liable, if there's anybody behind you, you're liable to wreck the stream by this misjudgment of what the person ahead's going to do. because that'll
Yeah,
build
and
up.
I would argue too, I mean, you know, this smartphone app, it's measuring the product of the driver input, the vehicle dynamics and the roadway and the weather. I mean, you know, the lateral acceleration and position is not driver behavior, it's the output of driver behavior.
Right.
And, you know, so that's the other, I mean, at least with naturalistic data, I mean, if you're looking in the cab and you're looking at the driver, I would say, yes, you're measuring something about behavior. And maybe they had a really fast reaction time, but they had really crappy brakes on their car and they didn't stop in time. I mean, so, you know, I think as human factors, people, well, I often see people forget about the vehicle part. And they talk a lot about, you know, the driver, and then I also see civil engineers who are measuring cars that talk about driver behavior. And I'm like, yeah, you're really kind of measuring cars, you know. And yes, those are people in the cars, but, you know, they're also in a context.
I have a couple of questions. How many do I get, Paul?
I didn't leave, let's do it.
The NIDA and its marijuana study conducted at NATS. Could you speak a little bit about that, especially in the context of simulators? I think that's a really nice example of what you can do with the simulators that you can't do out in the real world, but perhaps there are naturalistic driving studies that can have this model of testing alcohol and drug influences.
So, yeah, so Mads ran a study, Tim Brown, that was a controlled dose, 2 levels of alcohol, 2 levels of marijuana, and combinations therein. So the same person came back for 6 visits. It was a very involved study. And they drove actually this nighttime scene that we've used in other studies. So reusing scenarios is a good thing because we can compare that now to drowsy driving. You know, we have other data from other drivers on that. And the question that NIDA and NHTSA want to know is, you know, there's no BAC equivalent for marijuana. Marijuana stays in your system a really long time. And so they don't know what if I do a blood test, what was actually your level of impairment of performance. You know, there's a lot of studies done in the 70s to say 0.08, you shouldn't be driving. You know, you're however they define performance. So, you know, I think that kind of study where we know what dose they had and we got them into the simulator and we had rising in levels, you know, we were taking blood samples left and right and, you know, so you can tie to it. And there's certainly cases in several naturalistic data sets, and you guys probably have it too, that where you suspect they are impaired from looking at them driving, but you don't know how much they had or when or what they had. So I think, you know, that's probably a good study where you probably need both, but, you know, you couldn't really do that stuff. I mean, I can't get people high and then go send them on the road and say, yeah, see you tomorrow.
We call them again.
We drive.
In some of the studies, especially one that you described going into town, speed was crucial, and speed perception in a simulator can be very, very different than reality. How do you handle that, and how often do you get feedback from drivers, participants that said, wow, I didn't realize I'm going that fast?
A lot. I mean, I was surprised it was that matched the real world speed so well. I mean, I really was, because, you know, I think everybody's perception in the sim is like I'm sort of floaty, or I will say, you know, the high frequency vibration on the wheels really is the best. You know, if you were going to do 1 degree of freedom of motion, that's, you know, get the washing machine, you know, motor and rattle those wheels, because, I mean, in terms of increasing speed perception. So I don't know. I mean, I guess that's my point is, okay, everybody says they don't feel like they're going the right, you know, I can't believe I'm going so fast, but when you look at that compared to the real world speed, they were actually pretty close, you know, so maybe it's not as bad. Or are we just measuring speed limit compliance, that they can read the speedometer? You know, maybe it had nothing to do with their feel of the road, it had to do with their ability to say, oh, I have to go 3 now. So I think it would be interesting to do that study without speedometer.
have very nice metrics comparing the NDS and simulator. So
Data
what's your,
Shinar had very nice metrics.
so what's your 5 top factors in decision making to pick a simulator study or NDS, other than the cost?
No, other than the cost. I was gonna say money, 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 money. I think the behavior I want to study, and can I measure, how can I measure it? What am I measuring? Is probably number one. And then whether or not I'm trying to do a controlled study where I'm evaluating A compared to B, would kind of push me probably back toward wanting to do some lab test track or something. My subject population, older people are much more likely to get sick in the simulator. That's probably, that would be my top 5. And often we can't get eye tracking data on anyone. You're having big trouble with that, right? I don't know. I think those are, I would probably say those 3 right there. I mean, yeah, it's the research question. I mean, it's, there, at some level too, though, there has to be who's your audience for it? And is it going to be, is your audience going to buy it? I mean, I've been in a lot of simulator tours, and a city traffic engineer walks in, and if you've got a 6-inch edge line where there should be a 4, it's like, oh, that's not real, and they just dismiss it. And I would always argue to the RTI, like, you guys have to look at the sign manual. You can't keep putting these goofy signs because everybody's dismissing it on this very cosmetic stuff. But there is, it's more compelling, if you can show some NDS face video of somebody having a near crash because they were texting. That's much more compelling as a safety message, public safety message, than somebody sitting in a simulator. So I think there is sort of that audience component.
One more, sorry. So it seems in the past couple of years there's been a resurgence of interest in simulators given the human factors aspects of automation and connected vehicles that we study. What do you think about that? We are biased, but we think it's a really good tool for studying some of these things that's not out in the wild yet.
Yeah, I think if you want to study something that doesn't exist yet, a simulator is great. Would I want to study driver adaptation in a simulator? Probably not. The University of Iowa did 20 years ago in the Iowa driving simulator, and they had people come in every day for 3 weeks and drive this automated vehicle to work every day. And they saw some adaptation over time, but transfer control, sure. Mornings, HMI stuff. So again, I think it goes back to the research question. On the connected vehicles, we were able to trick connected vehicles through geo triggers and stuff on a closed course, just like we would in a simulator. I mean, I've done connected vehicle stuff both in a closed course and a simulator. It's certainly easier to do in a simulator. You don't have to worry about triggers. I think there's also, especially with automation, I mean, there is a risk to doing it on our own, safety risk, system failure. So you don't want to have this catastrophic system failure, which you can do in a simulator safely and see what people do. Okay. Dave, Dave.
Just a comment, and I think you alluded to it. NDS doesn't have to be the big fancy box with the 5 radars and the cameras anymore. There's a lot of studies that are getting naturalistic data through cheap means of data collection. David Evie and Lisa Molnar here are doing a study with just GPS. Connected vehicles are going to open up a lot of avenues to cheaply capture a lot of vehicle data. I mean, it's kind of all about models. Essentially, in the end, you want to get this data and create models so that you don't have to always collect data too. So it's like the title of your talk. It's not either or. It's sort of
Right. Yes.
Just a quick one. One of the things that you mentioned was similar sickness that can really affect results. And there's in literature there's several tests that are given to subjects to see some that are more or less susceptible. I mean, have you used these things to see what impact they have, how well they filter subjects?
Yeah, in fact, Chris Schwartz has a paper on that, because we use the Kennedy Simulator Sickness Questionnaire at NANS for 15 years. I mean, we have data going way back, and he actually looked at driver performance as a function of some sickness. You know, I would prefer to stop some sickness before it happens, and so there are screening questions that we would ask before they ever came in, and even my lower fidelity simulators. And that raises the issue of like, who are you screening out? Like, what have you just done to your subject sample by screening all those people out that get sick? Or Mike's doing a study now that's thermal imaging, so you can't have a beard, you can't have glasses, you can't just say that kind of thing. Like, okay, you just knocked out. They're really having trouble finding men of a certain age that don't have a beard.
You had mentioned that you can tailor the scenarios to reduce sim sickness potential. Have you seen any products that, because we've been looking into some different products, like different
Yeah, we used to do the wristband
wristbands
at my old drive safety one. We used to do the cruise thing that puts a pressure as a pressure point. I think there can be a psychological benefit. I mean, if people believe that's going to work, then it often works. And the biggest thing, at least in my old drive safety that was a full cab, is I removed the windshield altogether. And it got better airflow. It evened out the brightness from the front screen to the side screen because the tint on the windshield made it less bright to the front than the roll down windows on the side. And no one ever noticed. We never could figure out how to disable the wipers on the car so people would do wipers. But I remember I was always trying to get people at Federal Highway to take the windscreen out. And it's good, there's less glare because you have projectors, right? Yeah, so there was just, I don't know, nobody ever noticed. I mean, every once in a while they go, oh, and you didn't have to do anything. But call an Acme Glass to say, come take the windshield out, and they say, come bring the car in. And you're like, no, I'm on the 3rd floor. So yeah, I do. We really got the point at NADS. Peppermint, like one of my research assistants really believed that peppermint, there was a study I just saw about cinnamon, like about other, sucking on pepper, so she always had peppermint alkaloids for people. But I also think we almost put too much emphasis on it. It's probably, we kind of convince them that they're going to get sick. Because with all the other E4s talk about getting sick, you're going to get sick, and I'm going to ask you this questionnaire about getting sick. And it's like, they can have a taco for lunch and suddenly they're sick, So sometimes with some people, we just sort of started putting less emphasis on it in the briefing.
Don't prime them.
Yeah. No, that's not to say people don't get sick, right? All right, thanks.
I will